Welcome to another video. So today we're looking at oxidation and reduction, right? So let's get into it. So oxidation is the addition of oxygen to an element or a compound, or it's the loss of electrons, right? So any element that is oxidized, that means it has added oxygen to it, or it has lost electrons from itself, right? And then reduction is the opposite of that, which is the removal of oxygen, or it's the gain of electrons, right? So students normally use the acronym oil rig. So oil rig, which tells us that oxidation is the loss of electrons, while reduction is the gain of electrons. All right, so we're going to look at that further. Well, we need to know this term here that says the oxidation state or the oxidation number, right? So this number is basically the ion form of the compound or atoms, right? So if you normally see like Ca2+, right? This is the ionic form of calcium, which tells us that calcium will actually donate or give 2 electrons, right? So that's the number beside the plus sign that tells us the oxidation state or number of calcium, right? So let's look at some rules in determining what's the oxidation state or number of specific elements or compounds. So the first one is elements that are not combined or molecules have an oxidation number of 0. So what that is saying is if we have oxygen gas, the oxidation state or number here is 0, right? Because it's not actually done through ionic bonding, right? Or if we have just calcium sitting here, then the oxidation number is 0 because it's in its unreactive form, right? Now, for transitional elements, those are the ones in the center of your periodic table, they have varying oxidation number, right? So you sometimes will see like Fe2 or Fe3. These Roman numerals actually specify how much these elements will donate because they're metals, all right? Now, compounds' total oxidation number is 0. So that means if we have NaCl, right, when we add both oxidation number of Na and Cl, we should get 0, right? But for polyatomic ions, right, so like NH4 plus, the total of these oxidation number of nitrogen and hydrogen should add up to give us E positive 1 for the ion form of that polyatomic ion. So remember, if it's a compound, the total is 0. If it's a polyatomic ion, then the total would be equal to the ionic form of that compound, right? And then we have some popular ones that H is a positive 1, group 1 elements, positive 1, group 2 elements, positive 2, group 3 elements, including aluminum, is a plus 3. Halogens, which are group 17, is negative 1. Oxygen, except in peroxides, is negative 2. And then we talked about the polyatomic ions, right? So we noticed that these oxidation numbers or states are actually the ionic form of these elements in normal, right? So group 1 elements lose 1 electron, so it's a plus 1. Group 2 loses 2 electrons, it's a plus 2. All right, so let's use this principle now to find the oxidation number of each of these elements present in our compounds or polyatomic ions. All right, so here we have copper chloride, right? It's a compound, so that means that we're going to use this rule here that says compounds total oxidation number equals 0, right? So we're going to find it for copper. So what's the oxidation number of copper? So we're going to give copper a symbol that we don't know, so we call it X, right? So we're going to plus that to chlorine, right? So we know that chlorine is a halogen, so it's a negative 1, so it's plus -1, and we have 2 chlorine here, so that's multiplied by 2 equals, so the sum of these two things will equal to 0. All right, so we have x plus -2 equals 0. And if we take over the -2, therefore x would be +2. And please note, we did not just write 2 here. We have to state, right, that it's a +2. So we put the positive sign to show that it loses 2 electrons, right? So copper in this case will lose 2 electrons to aluminum, to chlorine, sorry, to make copper chloride. All right, let's look at the second one here, and we're going to find it for carbon. All right, so again, this is an element, so total amount is 0. And we have hydrogen, 2 hydrogen here. Hydrogen in a state would be a +1. So it's +1 times 2 plus copper, which we don't know, so we're going to call it X. Carbon, sorry. Plus, we have 3 oxygen here. It's not a peroxide, so in this state, it's a -2. So -2 times 3, and this is equal to 0. So 2 times 1 is +2 plus X, and 3 2s is 6, so that's -6. Let's put the plus here, plus -6 equals 0. So if we have +2, -6, we get a -4. So we have x plus -4 equals 0. So if we take over the -4, we have x of carbon is equal to a +4. Right? Let's look at aluminum oxide. So again, it is a compound, so it is equal to 0. So we have 2 aluminum here, so we have 2x, because we don't know what aluminum is, plus oxygen again, it's -2, we have 3 of it, so it's -2 times 3, and it's equal to 0. So we have 2x plus -6 equals 0. We take over the -6, so we have 2x equals +6. We need x alone, so we divide through by 2, so we have x would be a +3. Right? And in that case, you notice aluminum here is a +3. Alright? Let's look at question 4. Now this here is a polyatomic ion because it's in a form of a ionic form right there. So that means the total would be equal to a -1. Right? So we have hydrogen here, which is 1 hydrogen, so it's a +1, plus carbon here, which we don't know, so we're going to call it X, plus oxygen, which is -2 times 3 equals -1. Right? So in this case, this is -6. This is X plus 1 here. So -6 and +1 gives us -5 equals 1. Right? So therefore, if we take over this, it becomes 6. So X would be +6 here. All right? And then finally, we look at calcium phosphate. And we're finding the P, right? So this is a compound, so the total is 0. So we have 3 calcium here. So that is 3 times +2 for calcium. Plus, we have 2 P's here. So it's 2 times X. Plus, we have 2 4s, that's 8 times 8 here equals 0. So we have 3 times 2, which is +6, plus 2x, plus 2 times 8 is -16, equals 0. So we have +6, -16, so that is 2x minus 10 equals 0. Alright, so let's fix this. So that's 2x plus -10. So we take over the 10, right? So we get 2x equals +10. So we divide by 2. So we have x is equal to +5, right? So this is how you would calculate the oxidation number of any element in a compound, in a molecule, in a polyatomic ion. right? So what we're going to do now is to actually look at the redox reaction, which entails you using oxidation and reduction. All right, so what we've noticed here is that all of these that we've just found actually gives us that these elements will actually lose electrons in these reactions. So in that case, they will actually be oxidized, right? So they're oxidized because they all have a positive number, so that means they're losing electrons, right? So let's look at now if we have the oxidation and reduction happening in a chemical reaction, how do we know which one is oxidized, which one is reduced? All right, guys, so the redox reaction. So the redox reaction takes place when we have both oxidation and reduction happening in one same reaction, or reaction, right? So remember, oxidation is the loss of electrons, while reduction is the gain of electrons. So for us to have a redox reaction, both reduction and oxidation has to occur. Yes, right? So let's look at this example here. So we have calcium oxide reacting with hydrogen gas to give us calcium metal and water, right? So just by looking at it, it's easy to actually determine which one is oxidized or reduced. And that's because there is oxygen present, all right? So remember we say that oxidation, right, is adding oxygen to an element. So therefore we can know that the hydrogen here actually got oxygen, so it was oxidized, right? And then the calcium oxide actually removed the oxygen from our product, so it was reduced. All right, so let's use the oxidation state or number to actually show that that's the case. All right, so let's look at calcium oxide. So in calcium oxide, right, we know that the calcium, let's say we want to find the oxidation number of calcium here. All right, so the calcium would be X plus, we have one oxygen, which is -2, and it's a compound, so it's 0. So X would be a +2. So we're moving from a +2, right? So in this case, we can have +2 here, we have -2 there. And hydrogen, because it's a molecule, then it is 0. All right, so we don't need to work that out. And then it moves to calcium metal. Calcium metal, it's not bonded to anything, so that's 0, right? And then the H here, because it's in water, we need to find it. So let's go with water. All right, so we're finding the H for water here. So that is 2x plus 1 -2 equals 0. So we have 2x, right? We take the negative over, so it becomes +2, so x is a +1. All right, so we have water here having a +1, oxygen is still -2, right? So let's look how we can use the numbers to determine which one is oxidized and which one is reduced. So we're moving from a +2 calcium to a 0. So for you to move to a +2 to a 0, then that means we have to give electrons, right? Because remember, electrons are negatively charged. So the only way to move from a positive to 0 is to actually give it a negative, right? So we're giving it negative electrons, right? So it becomes 0, right? And then if we're moving from 0 to a positive, right? So that means we're actually taking away electrons. So we're losing electrons, all right? So that's how we know that the calcium, so calcium would be reduced, right? And then the hydrogen, sorry, would be oxidized, right? Because remember, we're using oil rig. So the oxide, sorry, oxidized. So the hydrogen lost the electron because moving from 0 to a positive number, so you lose electrons, because when you lose, you become a positively charged atom, right? And then calcium is reduced because it actually was an ion, plus 2, then became 0. So it gained electrons to become 0 now, right? So what we're going to write is our half equations and our final equation, ionic equation. So the half equations, right, would be, we notice that the reduction part, let's just call it R, right, it's calcium, right? So in this case, we have the calcium 2 plus, right, because we just found that calcium is 2. So calcium 2 plus will be reduced meaning your gain, so we're going to gain electrons, and it became calcium metal, right? So we balance off the ion form, so we put a 2 here, right? So 2 negative, 2 positive, we get 0, right? And then the oxidized part is hydrogen, so we have H2, right? And it's going to become water, right? And in this case, we're not going to write water, it's the ionic form, so it's H plus 1 plus electrons, all right? So we balance off again, so we put 2 here to balance the H's, right? So it becomes plus 2, and then we'll put a 2 here, right? So we note that the 2 electrons lost here in oxidizers is 2 that was used in the reducing of the calcium. So therefore the net equation would be to add both, because we have 2 electrons on both sides, they will cancel each other out. So we have the Ca2 plus H2 to give Ca plus 2H plus. And that would be your net ionic equation for this reduction reaction, right? So these are the only things that will actually be used in this chemical reaction between calcium oxide and hydrogen. Now, to note as well that in redox reaction, sometimes it's asked to find or to determine which is your oxidizing agent and which is your reducing agent. And students normally get confused because they normally think that since calcium is reduced, then it's the reducing agent. But it's not the case. So your oxidizing agent, right, is the one that was actually reduced, right? So your oxidizing agent is the one that was reduced. Your reducing agent is the one that was oxidized. So in this case, your oxidizing agent, let's call it OA. So your oxidizing agent was the one that was reduced, so that would be the CaO. So your calcium oxide is your oxidizing agent, right? Because it will be the compound that will cause the next compound to be oxidized. And then the reducing agent, Ra, would be your hydrogen, all right? So let's use this principle now to work on that one, because we notice now that this does not have oxygen, right? So we can't just look at it and say, hey, this one is reducing, this one is oxidized, all right? So let's go. So again, we will determine our oxidation numbers, right? So we have chlorine here, it's a gas, so we know it is 0, all right? And bromine here, 0 as well, so we don't have to worry those out. So let's go with sodium bromide. All right, so we know, all right, both equal 0, right? So we know that sodium is in group 1, so it's a +1 plus bromine, right, equals 0. So bromine has a -1 charge. So that means sodium is +1, bromine is -1, right? And then sodium is in a compound, so it is still +1, and calcium here, chlorine, sorry, is a -1 there. All right, so let's look. So let's look at chlorine, sorry. So chlorine moves from a 0 to a -1. So that means it actually gained electrons. All right, so chlorine gain electrons, and if you gain electrons, you are reduced, right? And let's look at sodium is +1 here, +1 here. So sodium, nothing happened to sodium. And then Br moves from a -1 to a 0, right? So that means it was lost. So electrons was lost. So Br was oxidized, right? So Br is oxidized, chlorine is reduced. So let's go with our half equations again. Right, so let's go with oxidized first. So oxidized is Br, right? So we have the Br -1, right? And remember, oxidized is the loss of electrons, so it's going to go over here to be Br, right? Br2 plus electrons. Alright, so we notice 2 Br here, so we put a 2 here, so it becomes 2 negative, so we put a 2 here to become 2 negative there. And then the reduced part would be chlorine. So it's chlorine 2 plus electrons to give chlorine -1. Alright? So again, we have 2 chlorine here, we put 2 here to become 2 negative, so we put a 2 here. So 2 and 2. Alright, so the net equation would be the 2 Br -1, or you can just have negative there, right? Plus Cl2, right? The two same electrons get cancelled to give Br2 plus 2 Cl negative, right? And that's our net redox or ionic equation for this redox reaction. So in this case, our oxidizing agent, OA, would be, right, would be our what was reduced. And in this case would be our chlorine gas, right? And then our reducing agent would be what was oxidized, which is your bromine, which is your sodium bromide, right? So that's basically it for showing what is reduced, what is oxidized, what's your oxidizing agent, and what's your reducing agent. Alright, so thank you very much guys for watching today, and see you guys next time.